All right, folks, we are going to get started here. I'll give you 1 minute to quickly find your seats, please, and we'll get going with our first speaker. All right, we're going to get going with our last speaker to try to stay on time. Once again, my name's Ian Epp, and I'm the chair for the last session of the day here. So this session is the environment, nitrogen, emissions, and runoff. This session is going to have 3 short presentations without Q&As, followed by a panel discussion where you can ask all the questions you've saved up or any other questions you've held over from the day. I assume the speakers will be fine with that. And then we'll have a final wrap-up, a grower wrap-up session, just like we did yesterday with Jay moderating that. All right. So to start off, we have Dr. Claudia Wagner-Riddle, a professor in the School of Environmental Sciences at the University of Guelph. Her presentation is entitled A National Collaborative Network for Improved Nitrogen Management and Greenhouse Gas Metrics. Let's welcome her as she comes to stage.
Okay, good afternoon. It's a pleasure for me to be here. The last time I gave a presentation at Canola Week was still during COVID, so I couldn't see if you were awake, paying attention, looking at your phone or anything like that, but today I can. So anyway, I will get going with this because I have only 9:41 already. Okay, so CAN into ONET, I'm starting off by telling you what it's about and who we are. It's a collaborative research network of partners in academia, industry, and government. So you can see the Canola Council up there as one of our industry partners. We're 6 universities across the country and 2 colleges, as well as Environment Canada and Ag Canada. There's sort of, and there also we have international collaborators from the US and Europe. A picture here shows us this last October, the kickoff meeting. So the network was funded in May, so we're just kind of getting going on this. Our focus is on 2 linked goals for grain and oilseed production in Canada that will resonate, I think, with you. We've heard of this earlier today about nitrogen use efficiency and all the different formulas that were shown for it. Here I'm very simplifying it. Basically what you get out for a certain input. And this is also linked to the reduced carbon intensity, which is the emissions per product. These 2 are linked through the nitrogen cycle, where, as we know, the 1 kilogram of nitrous oxide is about equivalent to 300 grams of kilograms of CO2. And even though we all know that prairie soils are sequestering carbon or have in the past, that sequestration gets offset by these emissions. A colleague from Ag Canada, Craig Drury, has come up with this pipe and valve conceptual model where we look at the fertilizer coming in, we want it to go to the plant, but along the way we have losses. So the 4R approach, even though we heard Dan, I thought you were very negative about the 4R. I got left with the idea that, well, it costs too much, let's forget about it. Well, I'm going to argue here that, no, there is a place for the 4Rs. And the way it works is by adding these valves along the system. That's the pipe and valve model, where we prevent losses. Some of them we can measure, others not so well. But the whole idea is that then more goes into the plant, therefore you don't need to apply as much, so you can manage that with the 4Rs. Some of the gaps that we're going to try to address, we heard this morning as well about the soil potential to provide nitrogen, so that is something that needs to be considered, as well as the losses in N2 gas form, which are difficult to measure, but we have somebody in the group that is able to do that. and with the idea that we do have regionally specific practices that need to be considered. So our big motivation on this is improving metrics. So, and what do we mean by that? By representative metrics, which I had in the title, is that we hear a lot from producers, well, we are already doing some of this. You know, what metrics, do the metrics consider what we are already doing? So that is a big focus of our approach. So the components of CAN and 2.0net are 3 of them, which we could summarize into data. So benchmark studies for data, metrics, putting together a database that will also consider existing some other approaches across the country, and then models which will be used to improve these metrics. And finally, recommend policies or actions that consider economics and already the current BMP used. So one of the issues is we don't have good baselines. We don't know what in different regions farmers are already doing so that we can set goals based on the current use. Across all of this, at the bottom there, training is, we are academics, organizations involved that train students, which is sort of the workforce that will be working on these topics in the years to come. So I'm going to give you a little bit of a taste of each one of these components, starting with the benchmark studies at benchmark sites. Now, all morning we've been hearing about from agronomists that show maps with lots of locations. And what you see here are very few in the context of that work, but our approach will be consider these sort of like super sites where we're measuring the heck out of everything to really understand the process so that we can get better metrics. Because that one of the issues with these gaseous losses is that they're very variable in time and space. Therefore, if you don't do very frequent measurements, it becomes very difficult to understand them. So listed here, you see a common theme is the use of inhibitors or nitrogen stabilizers at all the sites, but then specific things that are more common for a given region, like, for example, in Ontario, we're looking at cover crops. What I want to point out is the 2 new sites in Alberta, and this is to cover some of the gaps in data and metrics for the prairies. And then, so I will next talk about this field towers and regional tower in a minute, but before that is in terms of soil measurements that we will do at these few sites are related to soil nitrogen supply using tracers so we can determine crop and use efficiency, the microbial processes, and then losses both in the form of N2O and nitrogen gas. So back. An example of the Saskatoon site, it actually is going to be moved a little bit north of here now, but we've been already measuring over the last few years. So what the site looks like is setting up a whole bunch of equipment that is quite expensive, so this is why we only have a few sites. But the advantage is that you measure 24/7, 365 days of the year, and you get these very quick variations that happen due to rainfall because we're measuring at very short time scales. At each site, we have 4 hectare fields. So these are representative more of a larger field as opposed to agronomic plots that, for a reason, are small. In the example of Lethbridge, so one of our new sites at Lethbridge College, and is looking at dryland and irrigated half of the field, and then with the nitrogen inhibitor and without. At Olds College, we will be looking at variable rate. So Dan, thank you for bringing that up because it is difficult to measure. So we will have half of the field with variable rate, with and without inhibitor, and then a flat rate. The tall tower is a new endeavor for us, but it will be part of USDA network of tall towers. So we've secured the CBC Yorkton transmission tower, where we will be putting sampling equipment at about 94-meter height, and then capture an area. This is a very much an approximation, but a very large regional area, so that we can verify the metrics, the national inventory, for example, at that larger scale. So in this map, you can see the measurement for the tall tower in Minnesota, who's our collaborator on this. It actually captures, over longer time scales, it captures continental areas, and under shorter time scales, it's a relatively shorter area. But we're very excited about this because it is the only tall tower in Canada. And like CBC or not, at least we're using the towers. I know I'm in Western Canada, so I have to say that. Okay, and they're not going to charge us anything. So in the metrics part, our effort will be that the current sustainability efforts are captured in these metrics, and this is both at the National Inventory Report scale as well as calculators. And the fertilizer use survey is, Fertilizer Canada is one of the partners. It will be used to kind of determine that baseline so that we then can chart paths in terms of, you know, if X farmers are already doing this, then, you know, where can we go with some of the 4 Rs? So expected outcomes, I think what I'd like to highlight there is this transparent, representative science-based metrics, as well as the trainees. So having trainees, usually in this area, we attract environmental science students. So for them to understand the realities of farm level, to make their recommendations is really important. And with this, I'll give you a bit of information. If you like to get involved, the partners that I was showing there could be seen as maybe the founding partners. We are a big tent, and we intend to be sort of the go-to place for N2O information that serves the industry. And with this, I have a red light, and I will stop. Thank you.
Thank you for that, Claudia. Our next presenter is Ian Clifford, the co-founder and CEO of FuelPositive Corp. He's going to join us virtual live. And his title is Farmer-Owned, On-Farm Green Ammonia Production. How does it work for me? Join me in welcoming him. Hello? Ian, can you hear us?
Yeah, now it's on.
I can hear you loud and clear.
All right.
Now it's on.
Hi there. Sorry, I heard you were having some technical difficulties. We had queued up just a short video that we had just completed on our system and the impact for farmers generally. And I wanted to show that. But I'll run through my presentation really quickly, and hopefully we'll be able to touch on that video at the end of my presentation, if I can keep on time. I'm just going to very quickly share my screen here. Let me see where it is. It looks like it. Great. I'm going to assume that everyone can see that.
All good.
Great. Okay, perfect. So once again, thank you. I'm so sorry I couldn't be there in person. I'm in Manitoba right now, and we just have so much going on here with the commissioning of our first system. Unfortunately, I couldn't take a moment out of my schedule, but I'm super happy to be here and hope very much to be able to be present next year once our system is up and running full steam ahead. We're a public company, so I'll spend the rest of my time reading our disclaimer. Just kidding. So, what have we got? This is a on-farm green ammonia anhydrous ammonia production system. It's the first of its kind in the world in that it is a farmer-owned system designed specifically for farmer producers to have their own means of production for their nitrogen input on farm. Our mission, of course, is to empower farmers. We want farmers to own the means of production in this circumstance, and I think it's really important that farmers actually have the ultimate control, especially given how disenfranchised farmers feel from the entire supply chain of in many cases, their most important and costly input on farm. So we've been working on developing this first system, which is a 100 metric ton anhydrous ammonia system. For the last couple of years, we've gone from something the size of a refrigerator to something that will actually support a 2,000 acre farm. This farm is just based in Sperling, Manitoba, just south of Winnipeg. And it is an 11,000 acre grain farm owned by Tracy and Curtis Hebert, who produce canola amongst many other crops. But they typically utilize between 450 and 600 tons of anhydrous ammonia per year. They approached us a couple of years ago and were really a perfect candidate for our technology. They're an innovative farm. They're very technology driven as farmers, early adopters of technology, and super interested in what this technology can mean for their operations. So this system was delivered to their farm in June of this year. We went through extensive commissioning and then hit a bit of a rough patch a couple of months ago related to some certifications, and we are just resolving all of that right now, and expect that we'll be up and producing ammonia at the end of this year. That's 2024. Manitoba is a perfect place for us to start. It's a green grid. You can't produce green ammonia without green electricity. It's got the politics are well aligned from what we're doing in terms of support, both for us and for farmers in this context. And there's just a tremendous opportunity in the province. Many of you will know we're transforming one of the most carbon intensive processes on the planet, which of course is all centralized production of ammonia, entirely reliant on fossil fuel, with a huge carbon footprint. So each of our systems basically eliminates 1.8 tons of CO2e for every ton of green ammonia produced, and those are Canadian numbers. So it's a profound benefit to the decarbonization of agriculture as it relates to nitrogen. The future for us in Manitoba, and we've been approached from all over the world to to house our systems and to build our capacity. We're starting in Manitoba, maybe because of all the boxes it checks that I just mentioned, but it's also a tremendous opportunity in terms of potential adoption. We wanted to make sure that we perfected the manufacturing and distribution of our technology before we go into other global markets, and that includes other Canadian markets as well. And we can talk about that. Later. The opportunity size potential for us as a company is vast. Manitoba alone, if we only captured 50% market share in anhydrous and UAN type replacement, it's over a $2 billion opportunity for us as a company. So you can see why we really want to focus in on one place, do it super well there, and then expand from that. Critically important that that farmers are given the opportunity and the control over this incredibly important input. Every farmer we talk to tells us stories not only of cost uncertainty, but also more and more supply uncertainty, which makes the 4 Rs even harder if you can't actually get your nitrogen into the ground when you need to. Having that on farm, having all the supply you need for any given fertilizing period, of course you can imagine gives a tremendous amount of security to farmers. Additionally, there's a lot of intangible value for this as well. So providing cost and supply security for the farmers that we're working with also helps them with succession planning, next generation planning. If they can eliminate one of these massive uncertainties in their operations, it makes their operations that much more secure for the next generation to consider. And that's an intangible, what we call an intangible value for what we're doing. We're focusing manufacturing in Manitoba. We are in the process of securing our first facility, which would be an existing facility, about 75,000 square feet. And that lets us build about 10 of our 500 metric ton per year systems at a time, and about 30 systems per year. But the plan is, once we scale up, is to actually build our own facility in Manitoba that would allow us to produce 1.5 systems per day. Which we believe will help satisfy a very, very significant market potential in Manitoba and beyond. One thing I won't get into now because I don't have time, but there's a very interesting opportunity for doing fuel switching with green ammonia on farm for things like grain drying initially, but also the potential for operating internal combustion engines as well. But that's a presentation on its own. We were super excited to get going in Manitoba, and the rest of Canada is a massive opportunity for us, and then of course beyond that, the rest of the world. So happy to talk more during the Q&A if there's specific questions, and if not, feel free to follow up with me afterwards. And I don't know if the video can play now. If it does, then that's great. If not, let me know.
Almost half the people on Earth today are here because of our ability to make nitrogen. It's that important. Our DNA and RNA require nitrogen. And when we look at plants, nitrogen is required in harvesting sunlight. Since we've been able to produce nitrogen for the past 70 years, we've seen an increase in food availability, an increase in world population. However, there are implications of making such massive amount of nitrogen, and one of them is the use of fossil fuels. So green ammonia has that potential to reduce that massive impact, especially on the carbon footprint of the planet.
Currently, the ammonia industry is very carbon intensive. So the production itself requires fossil fuel, requires a lot of water. It's all centralized. A lot of the ammonia has been shipped from across the world all the way here.
And over the last couple of years, farmers have seen the highest costs that they've seen in their lifetimes for nitrogen fertilizers.
FuelPositive is helping farmers to bring that back home.
This is the first full-scale system of its kind, putting the power directly with the end user, the farmer. This technology represented a way of disrupting a 100-year-old commodity market and basically saying, no, there's an entirely different way of doing this. being able to help farmers take control of their most important input and create cost certainty and supply certainty around that is a huge benefit for farmers.
FuelPositive is an innovator, and it's great to be a part of that. It is incredible to be on the Hebert farm in Sperling. It's seeing all the individual pieces of our technology come together on site.
We farm 11,000 acres, and we like to just do a better job every year on our farm. I do want to disconnect from fossil fuels whenever we can, because that market is very volatile. Supply is important, cost is important. We can lock in our production and our supply. We know where it is, right on the farm. So that's a big piece for me.
We've designed this technology so that it's really hands-off for the farmer. It has a tremendous amount of onboard intelligence. We monitor the system remotely as well. We take green electricity, we take water, we take nitrogen from the air, and then we put hydrogen and nitrogen together under pressure and under heat over a catalyst, and that produces ammonia. The system is modular, so each of these containers contain a different process. We believe that setting up Manitoba and ultimately Canada as a center of excellence in green ammonia production is an amazing opportunity for us as a company.
I understand the great impact that our technology has and what it can do for both the environment as well as for individual farmers, make a huge difference in their lives.
I think every one of our team members really believes in this technology.
It takes a lot of heart from both the people from FuelPositive and the engineers and everything to make something like this happen.
All of us have been working on it for years at this point, so to see it come from a paper space to arrive on site and see it with a green backdrop in a field and its application is it's so rewarding. Direction that they want to see the company go in is something I firmly align with in terms of treating people, treating our land, treating our planet as it should be treated, just with respect.
Making green fertilizer is necessary if we're to achieve balance with the atmosphere and the land.
For a business to be successful, it's not only measured in profit, but also in the positive impact we have on the world around us. We're sharing this earth with a lot of different species, and it's not just about us and what's best for us, it's about the environment and the animals and the impact we'll have on a future generation.
All right, that was a great presentation, Ian. Let's hear from one more presenter. I'm going to invite up Blake Weiseth. Blake is the Applied Research Lead and Research Chair at Discovery Farm, and he's going to present on the environment, nutrient management to reduce loss.
Well, thanks very much for the introduction, Ian. So we're going to switch gears slightly. We've been talking a lot of the day on nitrogen, and rightly so, but shifting now to phosphorus. And in contrast to nitrous oxide emissions as the main sort of environmental parameter of concern, we're going to be talking about the impact of bioavailable phosphorus and its impact on surface water quality. So by way of introduction, when we talk about sustainability and the environment, I really like to seek for these sort of common messages we can rally behind that'll resonate for a diversity of stakeholders. And for me, in relation to phosphorus, I think about phosphorus use efficiency. And I think this relates to nitrogen as well. But regardless of who we are across the spectrum, I think we can rally behind this. So how can we maximize the amount of nutrient that's taken up by the crop, and by so doing limit what's lost from the system? And so from my perspective as a scientist, sort of the goal, and I think it relates to the agronomist as well, or the farmer, can we predict where these nutrients are moving throughout the soil, plant, runoff water system as influenced by the management strategies that we're using? And so for our nutrient stewardship practices certainly have an influence there as it relates to their impact on nutrient availability to the crop or its mobility in runoff water. And we're highlighting the spring snowmelt runoff water, because on the Canadian prairies, that is the main hydrologic event, where we get, the snow can result in about only 30% of the annual precipitation, but it can translate into greater than 80% of the runoff, because we get this rapid release of meltwater. It can be over frozen soils, which has this influence on its mobility. And so I have a diagram here up on the screen if we want to talk about some of the major pathways of consideration. Well, we start with the white dot here on the side of the hill slope, and this, of course, is snow. So we have that snow, and it represents a certain amount of water, of course. We can express this as snow water equivalent. And so in this sort of characteristic pattern across the Canadian prairies, in our prairie pothole region, you have this cycling of upslope, midslope, and depressional locations throughout the field. This snow accumulates and it melts, and then it's going to move somewhere, of course. And so we get this interaction as it's moving from the upslope position to the depression areas of the field. We see some interaction with crop residue as it's accumulating on the surface following a harvest operation. And that residue can contribute a significant portion of nutrients into the meltwater, as well as it undergoes the freezing and thawing cycles that we see here on the prairies. We have that, as I mentioned, that water will accumulate in the depressional areas of the field, and this may necessitate the interest of a grower in managing their water on the landscape. And so this may be in the form of constructing surface channels to channel that water to an approved outlet, so the use of surface drainage. And we know this water is interacting with the phosphorus in the soil tests phosphorus, and we are seeing some infiltration as well. So I highlight that just by way of introduction to lead into the study, which I'll be talking about through the bulk of this presentation. And what you're looking at here on the screen on the left is a satellite image of our field site near Langham, Saskatchewan. So what you're seeing in red is the outlines of 8 polygons which delineate the boundaries of these mini watersheds, if you will. Think of them as sloughs or depressional portions of the field. They would accumulate with water seasonally, but oftentimes by midsummer they'd be dry. So it may influence your ability to seed these systems from the spring melt, which then necessitates the interest of doing the drainage, which is the location of the teal lines. So you can see those that are channeling that melt water from the basin to, in this case, a permanent wetland in the middle of the property. So recognizing the importance of retaining water on the landscape where it makes sense. Now, we did that as the first phase of the project. The second phase then is to actually follow that up with a research study. So we're looking at different management practices, and I guess the question that arises is, you've done a water management strategy on your land. What role do BMPs have on mitigating some of these potential losses from the system? So we had, of course, a control treatment. So there's a status quo annual grain crop managed according to a fixed fertility application rate. And this is in contrast then to the second treatment, which is a variable rate fertilizer application, where we reduced our nitrogen and phosphorus inputs by about 10 to 20% relative to the control. The third treatment is a light post-harvest tillage operation. So ton firmly planted in cheek, but in terms of the comment that was made about the question of tillage, perhaps there is a place for tillage in some of these systems. And the idea is, can we incorporate that crop residue into the soil? We know phosphorus is immobile in the soil. Can we fix it and therefore prevent losses from the system? And finally, with the annual forage crop, the idea here, many of these depressional areas of the field can be elevated in soil salinity. Annual forage crops tend to be more tolerant to salts compared to grain crops. So can we get something growing in these systems to export those nutrients from the field? And the other benefit of this treatment is we see the ability of further reducing our nutrient application rate relative to the control. We know we tend to fertilize forages less aggressively than annual grain crops. So just briefly on the variable rate fertilizer treatment, so this was done in collaboration with SWOT Maps. We heard from Philip Harder earlier. This is the system that they use there. So just very briefly, what you see in the image in the middle is indeed the SWOT map for this site. It's the proprietary system of delineating soil management zones within the field. The idea then is you can match your fertilizer application rate to the predicted demand for those nutrients. And so essentially what we're doing in the image on the left in this in the table is we are generally reducing our nutrient application rates to these depressional areas of the field, recognizing that they tend to be accumulating of residual nutrients. So let's get into the results. So what we're looking at here, you can see the 3 crop types across the top of the screen, grain and straw yield, and for each of the treatments across the side of the table. What I want to draw your attention to really is the comparison of the control to the variable rate fertilizer treatment. So across the years and the grain and straw yield portions, no statistically significant difference in yield. And so another way to say that then for this VR fertilizer treatment, we're achieving statistically comparable yields to the control despite a reduced fertilizer application rate. Now you'll note that within a given year, there's sort of this variable performance of the variable rate fertilizer treatment. In 2021, the yields were essentially comparable to the control. In 2022, about a 4 bushel per acre decrease relative to the control, but in 23 with canola, a 12 bushel per acre increase. When we look at where the nutrients are moving from the system in terms of what's being taken up by the crop and then what's lost in a snowmelt simulation experiment that I did, what I want to draw your attention to again is this comparison of these treatments where we see in absolute terms in every year the variable rate fertilizer treatment is resulting in a reduced concentration of phosphorus in the meltwater, and we see this magnified when we look at the forage mixture treatment as well. Moving on now, show this video here, which is just to show the losses being measured in the field. So at each of those locations where the ditches channeled that runoff water have a calibrated weir. So you can see the meltwater running through from the spring. As we pan out, you'll see a black PVC pipe, which has a pressure sensor, and applying some principles of physics, we can measure pressure due to the flow of water, and that translates into a flow rate, which is important because when we think of losses, we want to measure the concentration, but also the flux. It's the total load of nutrient that we're interested in. And I mentioned that when we look at the results coming out of the field. So we have in this table on the left side, first of all, reported SRP. This is the dissolved inorganic phosphate. When you compare these treatments again, in every year, we see a significant reduction from the variable rate fertilizer treatment relative to the control. When we go to the estimated phosphorus load that brings in this volume, we see a bit of a different and more complicated story. In 2023, the VR treatment reduced that total load by about 50%. Very interesting and positive result. But in the spring of 2024, we see that the VR treatment had a greater load, and the reason is, if you see that column labeled area runoff coefficient, this is the amount of water moving through the system. So we have a greater amount of water running through that system, and even though the concentration is lower, we get a total load that's higher. And so this is one of the challenges, I think, as it relates to sustainability with phosphorus, is we can implement a management practice that consistently achieves one beneficial outcome, but it may have a variable performance by another metric. So what's the best metric we can use to measure performance? So just in closing here, what we see, variable rate fertilizer application resulted in statistically comparable yields to the control in every season, despite that reduced application rate. We saw a reduction in the concentration of phosphorus in the snowmelt water, but when it comes to load, we saw this influence of management practice really having an influence on the total nutrient load. So an area of future research might be hearkening back to previous conversations, looking at straw management and maybe that ability to reduce that total load of nutrient from the system. And with that, I'll close. Thank you very much.
All right, I will call up our other panelists, and then we can have our panel discussion. Alrighty, again, panel, Ian has joined us as well. So if you have any questions, please find a mic, and I know there are a few questions online. So we'll have, 10 or 12 minutes for this panel discussion. Maybe Warren will start with one online.
Sure, there's a few for, here we go. There's
A few for Ian online here. The top question would be, what would be the life cycle of these green ammonia facilities, and what kind of training is required to run them?
Yeah, no, great question. So they're designed for multi-decade operation. We're working with Farm Credit Canada right now and BDC on amortization of the system, but we're looking at probably out of the gate a 25-year amortization backstopped by BDC to minimize risk for farmers with the new technology. In terms of training, the main training on the system for the farmer is hooking up the storage of ammonia to their nurse tanks, which is some farmers do that now. A lot of farmers have their supplier do that. So there's safety training around that. But other than that, as I mentioned, there's virtually no interaction for the farmer with the system, and that's designed intentionally to minimize the workload for farmers as it relates to having a system on farm. FuelPositive takes care of that management.
All right. I have a question for Blake. You talked a lot about phos, and we've kind of shifted from nitrogen to phos in your talk. Are you measuring other nutrients as a part of your study to see if the impact is? Again, you mentioned how one, you have cascading effects, or one, and then you have a different metric, you may be making something worse or different, or...
Yeah, that's a great question, Ian. And so in addition to phosphorus, I measured nitrate and ammonium in the runoff water. And I didn't really touch on it just for brevity, but the tillage treatment as an example, while we had designed or included it in the study for that potential ability to mitigate phosphorus losses, it resulted in increased nitrate losses in the runoff water. And this agrees with previous research that's been done that shows when you do, or a conservation tillage management system, to take the positive perspective, with reduced tillage sort of reduces those, that mineralization of the organic N, and therefore less nitrate leaving in the runoff water.
All right. Again, you can come to a mic in the room, or a mic will find you if you have a question. Let's do another one from online.
Sure, we've got one here for Claudia, and is the need for CAN N2O-Net to develop science-based metrics due to us not having them, or federal metrics being inaccurate?
No, I think it is to improving the metrics. So we have metrics, but as Dan mentioned in his presentation, currently things like if you use an inhibitor, that's not included, although I know there's been work done to include that effect. So I think it's improvement of the metrics. We are always a little bit behind in terms of the research results to what farmers are actually doing. So variable rate, for example, is something that is very difficult to quantify at the spatial scale. So although work has been shown that if you do sessional control, that does reduce emissions. If it's only the rate, then it's okay. Like, we have a lot of information, but if it's any other type of management, then it's more difficult to quantify. I have a question for Blake.
Go ahead.
I was wondering on your unit, so your experimental unit was sort of each little
basin. Yep.
And so they weren't like directly comparable, is that correct? Or?
So each of the 4 treatments were applied to 2 of the basins. So 8 basins total, and I implemented those the 4 treatments in 2 of the basins.
Because if there's more runoff, did that actually, it didn't have anything to do with your treatment, right? It was just
Well, I guess the one thing that I was sort of thinking, and I was really interested by Philip Harder's discussion on the straw, my working theory is that variable rate fertilizer treatment had a greater straw yield, maybe greater snow catch within that basin than releasing more meltwater. So I guess it kind of speaks to sort of what you were asking earlier, Ian, and I think it's one of the challenges when we think about sort of, environmental performance of BMPs, let's say, is I think the question we need to ask ourselves is like, how are we measuring success, So in one case, we might see a consistent result in X variable, but in a different variable, it might not be the same. Or even as it relates to nitrogen versus phosphorus, some of the BMPs that you may implement to mitigate nitrogen losses may not be the same for phosphorus and vice versa.
So based on today, you're going to add some more metrics into your research for next year. I assume this research is ongoing for another...
Yeah, we still have another field season, 2025 field season for this work, so.
Let's take another question from online.
Sure, another one for Ian here. What's the initial cost of the green ammonia system, and what's the annual cost per ton of anhydrous ammonia?
Yeah, and good questions. The 500-ton system, which is the system that we're getting 95% or more interest in Manitoba, has a cost of $4.5 million for the system itself, plus the cost of site preparation, plus the cost of storage. And we're working now on refrigerated storage as opposed to pressurized storage because it's a lot less expensive and a lot more efficient. So you're looking at around $5 million all in for a 500-ton system. The cost per ton is really mostly related to the cost of electricity, green electricity that's feeding the system. The only inputs in our system are the electricity and water for the purposes of producing hydrogen. On the Hebert's farm, they pay about 5.5 cents per kilowatt hour connected to the grid for their continuous load. So their production of ammonia from an operating cost perspective is around $550 target. There's a number of places we can improve that. And then the capital cost, we're looking at about $350 per ton for the capital cost. But that's going to vary in terms of the type of farm, their ability to write off the technology, and ultimately the cost of commercial gray ammonia. ROI being measured, of course, what's the delta between producing a ton of ammonia, green ammonia on your farm for $800, or buying it last week, a few weeks ago, the Heberts were paying just under $1,300 a ton delivered. So, so the big variable, of course, is the cost of electricity. We have lots of farmers who are very interested in running their systems off-grid, so with wind, solar, geothermal, hybrid systems. And if they can get their levelized cost of electricity down to, say, 2 or 3 cents for the next 25 years, then you're talking about a tremendous amount of cost stability, as you can imagine. So I hope that answers those questions.
Do we have more questions online?
Well, I've actually got one. Since I have the mic, I'm just gonna take advantage of it. So it's for Claudia, actually. And I'm still kind of fascinated by that tall tower approach. And I'm curious, how is that representative of the area that it's monitoring when we've got some very different production practices and regions within that area? So I wonder if you could explain that a little bit more.
Yeah, so it is an iterative model. So you use what's going on in the atmosphere, you use an initial estimate of the emissions in the area, and you look at the concentration and say, well, how is that matching? And if it doesn't, then you change your sources. So it's not an area that I'm an expert in, so we have people in the group, but it's not going to be useful to say farmer X should do or is emitting this much. It's the aggregated value. So then you take the aggregated value and you compare it to what is Environment Canada predicting for this area and how close are we, or what are improved models predicting. So that is its value.
I think we have time for one more question. Do you have one more, Warren? Oh, in the back.
Hi, this is a question for Ian from FuelPositive. So I was just wondering about the water usage of your system and also the safety of the ammonia for liquid ammonia.
Yeah, absolutely. So in terms of water usage, for our 500-ton system produces about 1,500 kilograms of anhydrous ammonia per day and utilizes a little bit over 1,500 liters for that process. So it's not a lot of water, I guess is the best way to put it in terms of water intensity. One of the big problems when you talk about large-scale centralized production of green ammonia is that you have a huge concentration of energy and you have a huge concentration of water requirements. So it's problematic to scale up to large-scale ammonia production. So something to look at as you look into the future of green ammonia. On the safety side, the safety is really all around the storage, which of course is heavily regulated by Transport Canada, and Fertilizer Canada have some very clear regulations, voluntary but very, very good. And on top of that, then of course there's emergency planning around storage in terms of first responder and safety. So there's setbacks for storage, there's setbacks for the whole system, all of which are relatively straightforward. So far we haven't had any issues in terms of regulation. Of course, each jurisdiction is different, and this is the first system of its kind. So I'm sure we're going to run into all sorts of different situations. But right now, where the system is quite straightforward.
Thank you. All right, I think we're out of time, but thank you to all the panelists for the great discussion. I'm going to turn it over to Jay for our farmer panel.
Guys in the back, it's okay if we stand up. Cameraman, does that work yesterday for capturing? We'll try that again. Alan, Cody, Chuck. Can the crowd see, or do you want us to be on stage? It's okay, right? Yeah, whether we're sitting or standing, yeah. Yeah, got Cody. Good. All right, we're going to try it slightly different. I told her we're going to do oh yes for things that we want to see more of, oh no for things that farmers maybe are a little bit apprehensive about, and huh for things that they're not sure about. So Alan, what do you want to start with?
Probably what I'm not sure about. So
Huh?
no.
Okay, go for it.
What did I write down here? So, probably I had it more like things that make me nervous.
Okay, yeah, go with
So
that.
the first thing
That's
that
the
made
oh
me
no.
nervous could be summed up in 4 words, and it's environment, Canada, and climate change. And it gets right down to we've got a whole bunch of policies and stuff that are coming from the government based on sometimes a little bit sketchy type science, I think. But anyway, that scares me a bit.
Oh yes, oh no, or huh, Chuck?
Yeah, I agree. That's. Here, take this. Yeah, I agree with you, Alan. That's very scary when decisions are being made often just because of a calculated number, which is the National Inventory Review, rather than looking at actual practices and end results. So I think that's an area where it would be really nice to see more of the research that's going on when it comes to exactly what farmers are doing and are trying to reduce their emissions, and then, what other things might be able to do in that area as we go forward to 2030.
We have a new face today, Cody. Cody Nagy is the chair of Sask Oil Seeds Research Committee. Yeah. Cody, what do you want to address first?
Well, what makes me nervous is the nitrogen use efficiency, and sounds like it's going to be quite difficult to increase that. And so from a farmer perspective, how do I create more yield if nitrogen maybe is not the limiting factor? So there's going to be a lot more issues we have to deal with, and what are they? I think nitrogen's the first one that comes to mind. You can just put more on and maybe get more, but if that's not the answer, what is the answer, and how do we find it?
Yeah, what's your next most limiting nutrient? Yeah. Alan, what else you got there in that sheet?
Well, it's a mess. It's got a little bit of everything. So was like, well, jot stuff down,
Okay,
scratch it out, do
what's
this,
the
do
next
that.
most important thing you want to say on there?
Let's see.
Can you even read that writing?
Well, actually, I can't. It's kind of like a doctor's prescription. It's not that good. I don't know. I guess we're probably revolving sort of around the same thing here, but we're looking at trying to do more with less, which is fine. That's probably the ideal. So nitrogen use efficiency, stuff like that. But we start seeing stuff like cost of production increasing and basically my income declining. That seems like probably a recipe for future disaster. So stuff like that. See, I'm just on the negative. We need positives today, don't we?
I don't know. It's okay. whatever you want.
Yeah, the declining margins bother me. So it's like, okay, could we start studying stuff like, let's increase nitrogen production. Let's look at cropping intensity and just how it relates maybe to sustainability and stuff, to food security, to things that could be important to the country. So that, I don't know how you go about researching it, but to me, it seems like we need to probably continually improve food production for an increasing population.
Good bottom line. Chuck, what was one other thing you want to say?
Well, I mean, Alan's covered so many things here that I would like to say, but I really like one of your questions was, what would I like to try on the farm? And to me, that yield enhancement networking, that is something I think is, farmers do it in the coffee shop, but it'd really be nice to actually be able to have hard numbers and to be able to compare, what I'm doing to what my neighbor's doing, what things can really improve our production, or are there things that maybe we don't need to be doing that would reduce some of our costs? So that's one of the questions that you'd asked that I really liked. And again, like I say, what makes me nervous, it was very much about the BMPs and potential impact. Like some people say, you can't really reduce emissions using the 4 Rs. And then other people say, farmers are doing the 4 Rs and we do see some benefits from the 4 Rs. So it'd really be nice to get a clear-cut picture of what we can do to improve not just our nitrogen, reduce nitrogen emissions, but what we can do to improve yields. Because to farmers, it's all about, can I increase yields to increase my income, or can I reduce costs by making more efficient use of fertilizer to, again, reduce my costs and improve my bottom line. So it's always about profit and loss.
I was wondering about having another category in the YEN or the Yield Enhancement Network Awards for profitability. But
it wouldn't be a bad idea.
Cody, what do you think?
Well, just to add on to what Chuck said, and talking about doing on-farm trials and how important replication is. So you can't just essentially do one strip of each and take the yield data and think that you've solved an issue or found a new way to do things. So yeah, just the importance of replication and plot size when you try something new, and make sure that you're doing it correctly so you don't spend a bunch of money the next year on something that may not actually work.
So one thing about that Yield Enhancement Network, to that point then, so you'd be part of a club almost, and you would be able to, you'd try one thing, Chuck and Alan would try the same thing on their farms, compare results, and at the end of the year, you probably got some information that's quite valuable to you.
You could, yeah, as long as everybody was held to the same standards as far as doing the replications and the treatments.
Okay, good points. We're going to leave it there. Thanks, everybody.
All right, we are getting towards the end of our day. Thanks again to all our speakers today and all the attendees for your participation. The questions were really good all day. As noted yesterday, in lieu of speaker gifts, we are donating to the Keith Downey Undergraduate Scholarship at the University of Saskatchewan. For those of you collecting CCA credits, watch the screen, or you can scan the QR code on your name tag, and you can earn up to, I think, 14.5 credits for the full conference. So that is the end of today. Tomorrow morning, the timing is a little different. Breakfast starts at 7:30, and the Canola Innovation Day starts at 8:30. So set your alarm slightly earlier for tomorrow. And with that, we are off to the reception. There's a reception as per yesterday, sponsored by BASF, so you can head over right now, except the organizing committee and Clint. We need a picture of you apparently up front, so head to the front if you're the organizing committee. Otherwise, reception is over there. Thank you very much.